So here's a plane 4x plus 5y minus z equals to 2. Right? And you have some point outside of the plane. Okay. Now, how do you define the distance between a point and a plane? Well, a distance is the closest distance. That's what it means, right? It doesn't make sense for the maximum distance because this plane is infinite. So if you have some point here that's inside this plane, then this distance will be very big, right? So if you think about the maximum distance between this point and the plane, that's infinity. You can just go far as you want. Okay? So here, to talk about the distance between the point and the plane, it really means the closest point. Okay, and then for this to be closest, this must be 90 degrees. Do you agree? Yeah, that's the key. You have to have this geometric intuition in order to solve this question. That if you pick a point that is closest to this point, that point better be this line should be really perpendicular to this plane. Okay, so that already tells us what we want to do. We want to come up with a line equation whose direction is perpendicular to this vector and passing through 2, 1, 3. Right? So that's going to be step 1. And once we find that, then we're going to have to find out where that line intersects the plane to get this point, and the distance between these 2 points that we get will be the answer. Yeah. Because I didn't really think about this question beforehand. I'm afraid the final answer will be somewhat very messy, but it's okay. Yeah. So let's just try to figure this out. Okay. So step 1. What's this direction vector? Can you read that off from the problem? No, 2, 1, 3 is the coordinate.
4, 5, negative.
4, 5, negative 1. That's the normal vector to this plane, right? So step 1, find line equation whose direction is 4, 5, negative 1, and passing 2, 1, 3. Got it? Okay. And I've been writing down the equation of line in symmetric form, but here it's you'll see later in step 2 that it's much better to write down the equation in the parametric form. Okay. So direction vector, that's the velocity, right? That's how fast the particle is going to move if you're parametrizing the line. There's 4t, 5t, and then negative t. So if you differentiate this, you get that. So that will be the direction vector. And then it has to start at 2, 1, 3 in the beginning. So I'm going to put 2, 1, and 3. Okay? So that's the line equation. Now step 2, I have to find where that line passes through this plane. Okay? So the way you do it is by thinking of these as a set of 3 equations and this one as the extra 4th equation. If you take that view, how many unknowns do you have? X, Y, Z, and T. You have 4 unknowns. How many equations do you have? 1, 2, 3, 4. If the number of equations match with the number of unknowns, that means you can solve it. Okay? So we're going to try to solve this, and the easiest way to solve it is by plugging all of these into here. Okay? So it's going to be 4 times 4t plus 2 plus 5 times 5t plus 1, and then plus minus negative t plus 3 equals to 2. Right? Should be equal to 2. And then that's going to give us 16t plus 8, 25t plus 5 plus t minus 3 equals to 2. That's messy. I was afraid of that. Okay, so it's going to be 16 plus 25, 41, be 42t. And that's going to be 10, it'll be negative 8. So t is going to be negative 8 over 42. And if you divide top and bottom by 2, you get negative 4 over 21. Okay. And therefore, if you plug that back in here, you get the following answer. X is going to be 4 times negative 4 over 21 plus 2. So 42 minus 16 will be 26. Is that right? 16. 42 minus 16. You got 26 over 21. Yeah. And then y is going to be 5 times negative 4 over 21 plus 1. So that's negative 20, positive 21, so it'll be 1 over 21. And then z is going to be negative, so it'll be positive 4 over 21 plus 3. So 63, 67 over 21. Okay? So we see that, so step 2 is find the conclusion. Okay, and then step 3, find the distance. Okay, find distance. And the distance here is distance, let me write over here because I don't have enough room. So distance would be between 2, 1, 3 and those that point, right? So it's going to be square root of 26 over 21 minus 2 squared plus 1 over 21 minus 1 squared plus 67 over 21 minus 3 squared. And that's going to be, oh, okay, you just get 16 over 21 squared. And this is going to be, yeah, plus 20 over 21 squared plus 3 is gone 4 over 21 squared. And because 21 squared is common, I can bring it outside. And you get something huge. It's 256 plus 400 plus 16. And that's going to be 672. Okay. That seems like yeah, that's definitely divisible by 4. So if I bring the 4 outside, it's going to be 2, 1, 27 is 32, 8. Oh, that's again divisible by, okay, so that's divisible by 16. If I bring another 4 out, that's going to be 4, 41, no, 42. Okay, so that's the answer. Yeah, let me try to squeeze in another answer. So here's a quicker way to do it. This is like a long way to do it. But the second one, you don't necessarily have to find this point, just find any point. So the second solution is quicker you just find any point on the plane. How do you find such a point? Just put 0, 0. What's the z? You plug in 0, 0, what do you get for z? -2, right? So you just choose this. Since 4 times 0 plus 5 times 0 minus -2 is equal to 2, that means 0, 0, -2 is a point on the plane. Okay? So let's say this is 0, 0, -2. Now what you do is, you're just going to take this vector. So how do you get that vector? It's terminal minus initial, so you do 2, 1, 3 minus 0, 0, -2. So that gives you 2, 1, 5. Okay, that's this vector. But this is the line, and we're trying to find this length, not this length, right? We're trying to find this length, not this length. Okay? Yes.
Use Pythagorean theorem or
Okay, so that's one way to do it, but that's not so good because then you have to know this length, and that means you have to find this point, and we just saw that finding this point is hard. Okay, so there's another way to do this, something more elaborate, and the answer is you use the projection components. Yeah, see, what is this vector? We found out what this vector. This vector here is this vector, right? 4, 5, -1 is this vector. So what you need is you need the component of 2, 1, 5 over this direction 4, 5, -1. Okay. So let's see, what's the formula for component of u onto some big vector v? Well, it is simply the norm of u times the cosine of the angle between, which is same as u dot v, and then you divide by the size of v. Okay, so that if you go back to your notes, that's the formula for the component. So what we need to do is we have to do 2, 1, 5 dotted with 4, 5, -1, and just divide it by the norm of 4, 5, 1, -1. And what is that? That's going to be 8 plus 5 minus 5, right? Over square root of 4 squared plus 5 squared plus 1 squared, -1 squared. Which gives you 8 over square root of 16 plus 25 plus 1, which is 42. And if you use a calculator, this is going to agree with the previous answer. They look different, but if you use a calculator, you'll get the same exact answer. Okay, so this is much better than having to do it in 3 steps. So that's like one nice way to use the components.